We are slowly spiraling toward an inevitable meeting with our nearest large galactic neighbor, the Andromeda Galaxy. Both the Milky Way and Andromeda contain hundreds of billions of stars, and in just a few billion years, their paths will cross. Andromeda holds a special place in the history of astronomy. It was the first galaxy that truly revealed humanity's small place in the cosmos. For centuries, people believed the Milky Way was all there was, the very center of creation. But Andromeda proved otherwise. It showed that our galaxy was just one island among countless others spread across an enormous universe. Early views of the cosmos 100 years ago, people looking at the night sky saw the Milky Way only as a hazy ribbon of light. Without the ability to resolve individual stars, many cultures imagined it as a mystical bridge between heaven and earth. This view began to change in the early 1600s when Galileo Galilei, with his telescope, discovered that the Milky Way was made up of vast numbers of individual stars and planets. Later, in 1750, English astronomer Thomas Wright suggested that the Milky Way was actually a flat disk of stars, a groundbreaking step forward. Still, most believed the Milky Way was the whole universe. That assumption collapsed in the 1920s when Edwin Hubble proved that distant nebulae were actually separate galaxies, each home to billions of stars. One of the nearest was none other than Andromeda. The discovery of Andromeda, also catalogued as M31, has been observed for centuries. In the 10th century, the Persian astronomer Abd al-Rahman al-Sufi described it as a little cloud. Centuries later, in 1612, Simon Marius gave one of the first telescopic descriptions, followed by Charles Messier in 1764, who included it in his famous catalogue. By the mid-1800s, William Huggins studied Andromeda's spectrum and revealed it was not a gas cloud but something far larger. Modern observations have since shown that Andromeda is truly massive, about 220,000 light-years across and containing well over 1 trillion stars. A galaxy shaped by mergers. Astronomers now believe Andromeda is roughly 10 billion years old. Like many galaxies, it likely formed from the merger of smaller star systems long ago. In fact, evidence suggests Andromeda has been consuming smaller galaxies for billions of years, leaving behind hundreds of globular clusters as traces of its violent history. For a long time, scientists thought Andromeda was far larger than the Milky Way. But with improved measurements, we now know the two galaxies are closer in size and mass than once believed, nearly equal giants drifting toward each other. The active core of Andromeda. One of the most fascinating features of Andromeda is its active galactic nucleus, a highly energetic region powered by a supermassive black hole. This black hole is estimated to be over 100 million times the mass of our Sun. The intense gravity near the core causes stars to cluster tightly and radiate energy, making the center shine brightly across the spectrum. A future collision, the most dramatic chapter of this story, is still to come. Andromeda and the Milky Way are on a collision course. In about 4 billion years, the galaxies will begin merging, and the process will take around 2 billion years to complete. During this cosmic encounter, their shapes will warp under immense gravitational forces. Gas, dust, and stars will be flung into new orbits, while bursts of star formation will ignite in compressed regions. At the heart of the newly formed galaxy, the supermassive black holes from both Andromeda and the Milky Way will eventually merge into an even larger one. Astronomers predict the final result will be a single giant elliptical galaxy, sometimes playfully nicknamed Milkomeda. The impact on Earth. Although the collision sounds catastrophic, stars are so far apart that direct collisions between them are unlikely. Still, our solar system's fate is uncertain. It could be thrown into a new orbit, or even ejected entirely into intergalactic space. The birth of a new galaxy, the slow, inevitable dance between the Milky Way and Andromeda, is set to span billions of years. As the two galaxies draw nearer, their stars, gas, and dust will begin to interact in a complex cosmic ballet. Spiral arms will stretch and warp, pulled by the immense gravitational forces at play. Vast clouds of gas will collide, compress, and ignite, forming new stellar nurseries, regions where thousands of stars can be born in clusters at the same time. Over time, this intermingling of matter will give rise to a completely new galaxy, a supergalaxy often referred to as Milkomeda. While the original Milky Way and Andromeda were both spiral galaxies, the combined structure may become more elliptical in shape. Old stars from both galaxies will settle into more stable, elongated orbits, creating a dense, glowing core. Meanwhile, young stars, born from the turbulence of the merger, will shine brightly in clusters, injecting the new galaxy with vitality and color. Cosmic fireworks across the sky. From the perspective of any surviving planets, the night sky will transform into an extraordinary spectacle. Streams of stars will arc across the sky as gravitational forces pull them from their original homes. Dense star clusters will glow brilliantly, while shockwaves from colliding gas clouds will trigger bursts of star formation. Supernovae, exploding stars, will punctuate this cosmic drama, releasing energy and heavy elements into the surrounding space. These explosions, while destructive on a local scale, play a crucial role in enriching the galaxy with the building blocks of planets and life. Over millions of years, these fireworks will continue, turning the night sky into a dynamic, ever-changing canvas of light and energy. The fate of our solar system, the destiny of our own solar system in this galactic merger is uncertain. Simulations suggest several possibilities. It could remain in the outer regions of the new galaxy, orbiting peacefully as a minor star system among billions. Alternatively, the gravitational chaos of the merger could fling the Sun and its planets into intergalactic space, leaving our solar system adrift, isolated from the main galaxy. Even if Earth, or some other planet in our solar system, survives structurally, conditions will change dramatically. Cosmic radiation will increase, nearby supernovae could irradiate planets, and the gravitational reshuffling of stars may alter orbital paths. Any life that survives will have to contend with a sky that is constantly shifting and evolving, with new stellar neighbors appearing in close proximity. Life in Milkomeda. While humans will not witness this galactic transformation, the new Milkomeda galaxy may eventually become a cradle for life in distant eons. Planets orbiting stable stars could provide environments suitable for the emergence of new ecosystems. The merger will distribute heavy elements, the building blocks of planets, oceans, and potentially life, throughout the galaxy, giving future generations of stars and planets the raw material needed for complex chemistry. These new planetary systems may harbor life forms adapted to conditions very different from those on Earth. Perhaps some will evolve under skies filled with multiple bright star clusters, experiencing longer periods of daylight or intensified radiation from nearby stellar activity. The Milkomeda galaxy, in this sense, becomes both a tomb of the past and a nursery for the future, a testament to cosmic renewal. A universe in motion. The collision of the Milky Way and Andromeda is a vivid reminder of the universe's scale and dynamism. Humanity is just a fleeting observer in a cosmos that operates over billions of years. Galaxies collide, stars are born and die, and planets emerge and vanish, all on timescales far beyond a human lifetime. Yet through observation and imagination, we can witness the forces that shape galaxies, stars, and planetary systems. Studying Andromeda now, with advanced telescopes like James Webb and Hubble, allows us to glimpse these monumental processes in action. We can chart the paths of stars, map interstellar gas clouds, and model how entire galaxies interact, even if we will never live to see the full story unfold. The legacy of Milkomeda in the far future, the Milky Way and Andromeda will exist no longer as separate entities. Together, they will form Milkomeda, a galaxy that carries the history of two spirals and the promise of new life within its stars. The combined gravitational forces, swirling stellar populations, and enriched interstellar medium will create a galaxy that is simultaneously ancient and renewed. Though humans will have long disappeared from Earth, our understanding of the cosmos allows us to imagine this awe-inspiring future. Andromeda will stand as a symbol of the universe's capacity for destruction and creation, a vast cosmic tapestry woven from countless stars, clouds of gas, and the echoes of galaxies that once were. The merging of the Milky Way and Andromeda is not the end, but the beginning of a new chapter, a grand, ongoing story written in the language of gravity, light, and time. And through our telescopes and imagination, we can witness this story in progress, marveling at the beauty and scale of the universe in which we live.